Hello, I am Jay and I'm joined here with Kian and Travis. And we're going to be talking to you about the DELLve project that we have so far. So our project is broken up into three parts. The first part is the actual benchmarks that is running through cuDNN and measuring the algorithms. And then we're going to see how it runs on the GPUs. Then we have the second part in which we're going to be profiling the GPU and seeing how exactly it's running and sending it over through a socket so that we can look at this data from an external socket. And then we have the third part where we have the actual web application running, and currently we have all the mockups for that. The first part, I'm currently here logged in to the DELLve server that you have provided us, and I'm currently in the DELLve repo. So in this repo, within the bin folder, after you make the project, you'll find all of the different convolutions. So far we have the backward data convolution, backward filter convolution, and the forward convolution. And all of these are testing all the different convolutions that are available through cuDNN. And we're going to be passing different kinds of problem sets to them to test different GPU utilization, memory utilization, and all of them are testing different parts of the GPU. And all of these are located within the problem sets files as a CSV. So for an example, let's take a look at the high mem CSV. So here we can see these are all of the parameters that are that we're passing in, and at the very left we can see increasingly dense memory with each run. So when we run this, we're going to be running it, the first one is going to be about 50-60% memory, and increasingly 70% and up to 100% on the last problem set. So to actually run the benchmark, we're going to use the forward convolution bench today as an example. And for this, we're going to be passing in three different parameters: the problem sets, the number of runs, and the GPU that we want to run in. So to run the forward bench, we're going to pass in the high mem_2 CSV that we just looked at. So the current server, the device ID 1 refers to the NVIDIA Tesla K10, which is what we're going to be using to demo our benchmark. And finally, the number of runs. We average the amount of time that it takes for each of the benchmark to run across a varying number of runs. And the more the number of runs, the more accurate our data is. So for the purposes of this demo, we'll just be using 5 runs so that we can see it running and get through with it. So you can see here that it's starting to run all of the sets. The first set took about 512 milliseconds, and the second one increasingly longer, as we expected. So now we're going to look at the actual profiling data that Kian will be talking about.
Thanks, Jay. So first I'll talk about the actual profiler itself that will be running on the server. And so that is some Python code that uses the NVIDIA management library to query information about the GPU. And currently we're only querying for GPU utilization and memory utilization. We can query for other kinds of information provided through the API, but this is just for demo purposes. And so to start this server, we simply run python service.py, and this will now collect information from the GPU, store that in a protobuf message, and stream through gRPC at a specified socket. And now on the other end, to receive that data, I'm going to switch to a terminal running here on our local machine. This is basically the backend which will receive the data, read that in, and display it in real time. We currently have 2 versions for our demo. The first version is completely in the command line, and so we start that up by running node backend CLI.js, and we specify the IP address of our benchmark server along with the port that we'll be listening to. So that should start, and that will show us 2 meters for GPU utilization and memory utilization. And so we go back to the other command line we'll run our benchmark, and updates should be sent in real time, where we'll be able to see the progress here on our local machine. Oh yes. So that's a third problem set, memory complete. And when the benchmark is done, the GPU and memory utilization goes back to 0%. So the second version of our backend is a GUI, which runs in the web browser. And this will take in the data from the gRPC stream and display it in real time inside the browser using Socket.io. So let's run our benchmark again. And we can see the results within the browser itself. So what we have right now, this is simply a proof of concept. It's kind of far away from what we're expecting the final product to look like, but it's a good way to show that we are able to receive data and display the data from the server. And so to talk about what our final GUI will look like, here's Travis.
So this is a mock-up of what we envision the final web GUI to look like. This first page is going to be the dashboard, where the latest benchmark ran is going to display basic information such as GPU memory usage, power consumption, along with temperature. It's also going to display a benchmark score, which we haven't currently defined yet, but it's going to be standard across all the servers, and then there's going to be a question mark that'll define the score and tell the user everything the score takes account for. From this dashboard, you can also download the results and also run the current benchmark or the latest benchmark again. By clicking run again, it'll pre-populate the server that was tested and the benchmark that was ran. This leads us to the second page, the configuration page, which displays all the details of the server and displays the previous benchmark history, which will show a bunch of different tests that have ran on the same server and their score, as long as the ability to download the results. After a user has selected a server to run, as well as a benchmark to run, they can run it from this page, and then the next page, when we're done with it, is going to display live results of the GPU utilization, memory utilization, power consumption, temperature, and at any point in time, the user can choose to stop the benchmark, but we haven't decided if we're going to throw away the results of the benchmark or just give the user the results after it's stopped. So that just about does it for the web GUI. If you have any feedback about the web GUI, feel free to comment on it, and we'll try to accommodate your requests as best as possible.